Namaste everyone. Welcome to class 11, chapter 3, trigonometric functions, module 5. Today we are going to cover trigonometric identities based on sum and difference of two angles and their derivations and examples based on these identities. Trigonometric functions of sum and difference of two angles. Here we shall derive the trigonometric functions of sum and difference of two angles or numbers and related expressions. The basic results in this connection are called trigonometric identities. What are trigonometric identities? They are nothing but mathematical statements and they are always true and they are often used to prove geometrical and trigonometric problems and various mathematical concepts. Like we have already seen in our previous modules that sine minus x is equal to minus sine x, because you know minus of this angle describes that it is in the fourth quadrant, and in fourth quadrant sine is negative. And similarly cos of minus x is positive in the fourth quadrant. We shall now prove cos x plus y is equal to cos x cos y minus sin x sin y geometrically. Because once we prove this identity geometrically, with the help of this identity we can prove any other identity that we will see later. Now let us start. Consider a unit circle with the center at the origin. As you can see, let x be the angle P4O P1. This is the angle x, and y be the angle P1O P2. This is y, and angle P4O P2 makes the angle x plus y. And if we replace y by minus y, where minus y, negative y is the angle in clockwise direction, this angle which is P4O P3. Therefore, P1, P2, P3 and P4 will have some coordinates that you can see, because in our previous modules we discussed that coordinates of this point on x axis will be 1 0, which is cos x, the value of cos 0 and sin 0. Cos 0 is 1, sin 0 is 0. Now, since coordinates of point P1 according to this angle x are cos x and sin y, and coordinates of point P2 cos x plus y and sin x plus y depending upon the angle covered by this ray, and the coordinates of P3 are cos minus y and sin minus y according to the angle covered by this ray. Now, from this figure we can easily see there are two triangles which are P1O P3 and P4O P2 here, right. Now, in these two triangles, angle y and this is the angle made by P1O P3, and angle made by P4O P2 is also y and this angle, because here negative sign only represents the direction. Absolute value of this angle is y only. So, both are representing y plus this common angle. Now, in these two triangles, since these two angles are equal and also these sides are equal because they are radius of the same circle, and this is also radii of the same circle. So, these two triangles are congruent by SAS criteria. Now, since these two triangles are congruent and their corresponding parts will also be equal, we can say that P1 P3 will be equal to P4 P2. So, by distance formula we can find out P1 P3 squared is equal to cos x minus cos of x minus cos of y whole square, and then sin x here sin of y sin of x minus sin of y whole square. And before proceeding further, I would like to make it clear that cos minus y can be replaced by cos y, because cos minus y is in the fourth quadrant, which is positive, and sin of minus y can be replaced by negative sin of y. This negative and this negative will make it positive. So, we will move according to sin x plus sin y. Now, applying algebraic identity a minus b whole square, it will be cos square x plus cos square y minus 2 cos x cos y plus, opening this according to a plus b whole square, this will be sin square x plus sin square y plus 2 sin x sin y. Now, we know that like terms cos square x and sin square x together makes 1, and cos square y and sin square y together their sum makes 1. We can write in the next step 1 plus 1, 1 for this and 1 for this, minus 2 cos x cos y plus 2 sin x sin y. Now, 1 plus 1 is 2, and taking 2 common from these two terms, minus 2 common, here we are left with cos x cos y minus sin x and sin y. We will leave it here and we shall proceed for next distance, that is here P2 P4. Now, we will find P2 P4 applying distance formula. Here it is 1 minus cos x plus y whole square, and next is 0 minus sin x plus y whole square. After opening it through identity, 1 square plus cos square x plus y minus 2 cos x plus y into 1, that will not make any difference, plus 0 square plus sin square x plus y and minus 2 sin x plus y into 0, and this term will become 0. Now, the distance is, here we have 1 square, here cos square x plus y and sin square x plus y will together make 1. So, this one and sum of these two terms will also give us 1 minus 2 cos x plus y, and that is all, because we have already shown that this term is 0, and this can be written as 2 minus 2 cos x plus y. Now, comparing these two distances, as we have already told that these two are equal, we will show them like this. P1 P3 square is equal to P2 P4 square, because when distances are equal, their squares are also equal. So, here 2 minus 2 cos x cos y minus sin x sin y equal to 2 minus 2 cos x plus y. Now, I am removing this Let us compare these two distances. See here, on the left hand side terms and right hand side, if we compare, these two can be cancelled from both and negative sign can also be cancelled, and we are left with 2 cos x cos y minus sin x sin y equal to 2 cos x plus y. Again cancelling this 2, we are left with cos x plus y is equal to cos x cos y minus sin x sin y, and this was the geometric proof of our identity cos x plus y is equal to cos x cos y minus sin x sin y. And this is very important identity because we will be using it to prove or derive other identities. Now we need to prove cos x minus y is equal to cos x cos y plus sin x sin y, which is nothing but difference of two angles. We have just proved that cos x plus y is equal to cos x cos y minus sin x sin y, right. Now, with the help of this identity, we shall be proving this one just by replacing y with minus y. So, in this formula, what we are going to do is, we are replacing this y with minus y to prove this identity. So, here it will be cos x cos of minus y minus sin of x and sin of minus y. Now, as we already discussed that cos minus y is cos y. This is cos y, and sin of minus y is minus sin y. So, writing it again, this will become cos x cos y minus sin x, and this minus will make it plus. So, sin x and sin y. Now, we obtained this result on the right hand side by replacing y with minus y. Here also we will replace y with minus y. So, what we will get? Cos x minus y. So, this identity is proved. So, simple. Now, with the help of this identity x minus y, that is difference of two angles, we can prove cos pi by 2 minus x is equal to sin x. That you was already using in your earlier classes, but you did not know the reason. Now, we show you the reason. Just replace x by pi by 2 and y by x in this formula. X by pi by 2 and y by x. So, writing it cos pi by 2 minus x is equal to again cos pi by 2 and y replaced by x, sin x replaced by pi by 2, y replaced by x. Now, what do we get? You know what is cos pi by 2? Cos pi by 2 is 0 and into cos x, 0 into cos x will make it 0 only, and what is sin pi by 2? Sin pi by 2 is 1 into sin x. So, this term becomes 0, we are left with this term only. So, here you can see cos pi by 2 minus x is equal to sin x. Similarly, we can do it for sin when we will prove the formula for sin x minus y or sin x plus y. Now, what are co-function identities? We have already proved cos of pi by 2 minus x is equal to sin x, and similarly we can do others. These are called co-function because you can see cosine is complementary of sine, because in cosine we see co is there. Whenever there is a angle, difference of two angles, one of the angle is multiple of pi by 2, we can simply jump over this angle by removing co from here. And whenever co is not there, and we can jump over this angle which is multiple of pi by 2 by putting co, and co is complement of that angle. So, that is why they are called co-function identities, not only for difference of two angles, for sum of two angles also we call them co-function identities. And this pi by 2 minus x represents, this is pi by 2. When we talk pi by 2 minus x, this represents first quadrant. Therefore, all the ratios are positive in the first quadrant. When we talk about pi by 2 plus x, means we are talking about second quadrant, and in second quadrant sign is positive. That is why sign changes to cos x with the positive sign, and cos pi by 2 plus x is positive, negative in the second quadrant. That is why it changes to minus sin x. Now, we come to cos pi plus x and equal to minus cos x. How this is? Pi plus x represents third quadrant, and in the third quadrant cosine function is negative. Now, one thing, most important thing to note is that whenever students change the sign, they jump from this to this. Important thing here, we are not changing from cos to sine or sine to cos, because it is not multiple of pi by 2. This is pi, and pi is period of cosine or sine function. This will remain, cos will remain cos, or sine will remain sine, or any other trigonometric function will remain same whenever we will jump this angle to this. But the sign, the important thing is which sign is to be taken. While taking the sign negative or positive, deciding that, we need to consider the original function, not this function on the right hand side which we have converted. So, cos of pi plus x means cos in the third quadrant is negative, sine of pi plus x which is sine in the third quadrant is again negative. Now, pi minus x, when we are talking about pi minus x, we are again talking about second quadrant. So, in second quadrant we can write it like this, pi by 2 plus x also and pi minus x also. But when we write pi by 2 plus x, sine gets converted to cos x. When we write pi minus x, sine will remain sine with the positive sign in the second quadrant. Cos pi minus x will remain minus cos x, and similarly 2 pi minus x. Here 2 pi is when it terminal rate takes a complete turn, this makes an angle of 2 pi, and when we say 2 pi minus x means we are talking about fourth quadrant, and in the fourth quadrant, which is 2 pi minus x, sine will be negative and cos will be positive, and we can similarly take other trigonometric identities. Now, angle sum and difference property for sine function. We have just proved that sine of x is equal to cos of pi by 2 minus x. To prove this identity, we will be proving using this result. How? Like we know that whatever is the angle, we can put it here by applying cos. So, we can write cos of pi by 2 minus x plus y. Now, just by rearranging these terms, what do we get? We get cos of pi by 2 minus x and minus y. And instead of clubbing these two terms, we are clubbing these two terms together, and now applying the formula for cos of x minus y on this term. So, this will be in place of x, this whole, and place of y, this is there. So, this will be cos of pi by 2 minus x and cos of y plus sine of pi by 2 minus x and sine of y. Now, we know cos pi by 2 minus x is nothing but sin x, and this is cos y, plus this is sin of pi by 2 minus x is cos x and sin y, and this gives us the value of sin x plus y, the same property which is written here. So, this is proved. Similarly, we can prove it for difference of two angles just by replacing y with minus y. When we replace y with minus y here, what change we get? Cos minus y will remain cos y only, and this sin minus y will become negative, and this sign will change to minus, and we will get this identity. So, here is a proof for sin x plus y and sin x minus y. Now, angle sum and difference property for tangent function, that is tangent x plus y is equal to tangent x plus tangent y upon 1 minus tangent x tangent y. And before proving this identity, we need to ensure that none of the angles x and y and x plus y is odd multiple of pi by 2. Why? Because whenever we take tangent function, cos function comes in the denominator, and denominator should not be equal to 0. That is why we ensure that x, y or x plus y is not odd multiple of pi by 2. Now, let us start the proof of tangent x plus y. For proving tangent x plus y, we need to write it like tangent sin of x plus y divided by cos of x plus y. Now, sin of x plus y we have just proved, that is sin of x cos of y plus sin of y and cos of x divided by cos of x plus y. Expanding this will give us cos of x cos of y minus sin of x and sin of y. What is the next step? We now need to do it. We need to divide whole numerator and denominator by this term, that is cos x and cos y, both the terms. So, if we divide this, this will be sin x cos y plus sin y cos x divided by cos x cos y. Similarly, denominator also cos x cos y minus sin x sin y divided by cos x and cos y. When we divide this term by this term, here we see that cos y and cos y will get cancelled. We will be left with sin x upon cos x, that is nothing but tangent x. And when we will divide this term by this term, here which term will be cancelled? This cos x and cos x get cancelled. We will be left with sin y upon cos y, that is nothing but tangent y. And when we divide this term by this term, both are same. So, we will get 1 minus. Now, this term get divided by this term. Here which term will get cancelled? No term will get cancelled. Sin x upon cos x will give us tangent x, and sin y upon cos y will give us tangent y. So, tangent x into tangent y, and this way we prove this identity. Now, let us move further. Now, we come to double angle formulas. These formulas are most important formulas to be used in 11th class or 12th class or any other chapters wherever trigonometry is used. Now, why this is most important? This cos 2x, here you can see 2x. This represents double angle. This can be represented in 4 ways. Like whenever we need, whatever is the need, we can substitute these formulas depending upon our requirement. If we need cos and sin in squared form, then we can use this. If we need to convert cos of 2x in the form of sine function, we can use this. And if we need to convert it into the form of cos, we can use this. And if we want to convert cos into the form of tangent, then we can use this. Like you can see, cos 2x can be represented in 4 different ways. Now we will prove first property, that is cos 2x is equal to cos square x minus sin square x. Cos 2x. This 2x can be broken into cos x plus x. Now we will apply here the identity for cos x plus y. So, instead of y, we will put x again here. Now the identity is cos x cos y. But here in this case we will write cos x into cos x minus the identity is sin x sin y. We will write sin x into sin x, and this makes it cos square x minus, this makes it cos square x minus sin square x. This is sin square x, which is proved. Our first identity is proved now. With the help of this identity only, we can prove the next one. Now, that's all for module 5. Today we covered trigonometric identities based on sum and difference of two angles and their derivations, and we did few examples.